Hi and welcome to Geeks for Geeks. Can I have a quick plus one in the chat if I'm visible as well as equally audible? Then we would start right away. Right? Yeah, yeah. Actually, it starts in three. Okay, actually it starts in three, but the thing is that there is a delay. There is a delay in the live stream itself. Okay, it's just that when I just say something, it won't render to your screen directly when I say. Okay, it's just that it gets rendered after some time. Okay, just a sec. Let me. Yeah, good to go. Yeah. So today we would be doing the problem of the day, that is print binary search elements in the given range. Okay, and this is a problem which came in Amazon, Flipkart, and one more is Microsoft. Okay, and the success percentage is around 49%. It is an easy problem, I must say, but if you are not well known with the terminologies of trees, and if you're not well equipped with the recursion, then it would be a little bit problematic for you. Okay, and so let's start with the question. So hi Raj Sharma, Anmol Raj, thank you. Swami, yeah, okay, so we would start. So so we are given a binary search tree. Okay, now the first thing that comes to our mind is, what is binary search tree? It might be the case that at first we should know the terminologies that it does provide. The first thing is the binary search tree. We would be underlying it, and then we are given a range which is low and high. Okay, and find all the numbers in the BST that lies in the given range. Okay, and low and high are included itself. Okay, and then it is so said that elements greater than or equal to root go to the right hand side. Now at first we should know what is binary search tree. So I can't teach you the whole binary search tree. I would be just giving you an overview, but it is sufficient enough to solve this question. I would giving you the overview that is sufficient enough to solve this question. Now, what is binary search tree? Binary search tree is a node-based binary tree data structure which has the following properties. That's the normal binary tree data structure which holds the following properties. The left subtree of the nodes contain only nodes with key lesser than the nodes key. Okay. The thing is that this is 8. Okay. So suppose 8 is there and I want to put 7. Okay. If I want to put 7, then this side I can only put. If I want to put 8 or more than 8, then I need to go this side. Suppose I want to print 9, then we can go this side. Suppose I want to print 8, so we can go this side. Not print, actually I want to append. The It is the thing. So we would move forward. The right subtree contains only nodes which are greater than the nodes key. Okay, greater than the nodes key and less than the nodes key. But in the question that is given is equal to element are also on the right hand side. Good to. So the right and the left binary search tree must also be a binary search tree, and all the branches except the leaf should have the should hold the following property. Okay. By the way, Swami, I am extremely sorry. I would next day I would be trying to do is I would start streaming from 248 258 only. Then the thing is that you would be getting it live at around 3 only or before 3. Okay. So now let's start with the solving the input. So am I clear with the question or not? Because understanding this terminologies and this question and a special property is that the element that is greater than or equal to, that equal to part will go to the right hand side. Am I clear with this question or not? Can I have a quick plus one in the chat so that I know that we are all in the same page? Okay. So till you give me a plus one, I would be waiting. But till then, I won't be wasting your time. I would be trying to move forward. Okay. The thing is that 17. So 4 is this side, 18 is this side, then 2 is this side, 9 is this side. Normally. Okay. So then we are given that 4 to 24. Okay, and both are included itself. Okay, now what are the numbers that are done? That is 4, 9, 17, and 18. Okay, this is it. This is it. So 4, 9, 7, 18 are the elements that are inside. Now, now we can clearly see that we need to traverse this tree. Okay, to check the elements which lie within this range, we need to traverse the tree. Traversing is important because to check, suppose I want to check which are the people that that eat something. Okay, suppose they eat cake, so I need to check each of the people, na? In the same way, suppose if I want to check the elements which lie within this range, then I need to check. Okay, so now whenever this is a tree, whenever, okay, we need to find all the elements. Okay, so the thing is that whenever we need to print it in the lexicographical, that is non-decrease. Okay, that is non-decreasing, that is increasing. Okay, I am telling you non-decreasing. Non-decreasing means increasing, not strictly increasing but increasing. Okay, so we need to print it increasing. With recursion it can be done easily. Okay, Anmol Raj, the thing is that I personally feel that you have known the question, so it is the thing that I also know, but I am trying my level best to explain the other people. Okay, you and I know, but other people don't know. The thing is that if you directly tell the solution, then that won't be fruitful enough, because what I want to do is I want to take away many ideas that you would take home. Okay, these small ideas would give you greater perspective to solve a bigger problem. Okay, that is it, because it might be the case that same question might not come. It might be same, might little bit slightly different question might come. So I don't preferably give the direct idea. That's why. Okay, so the thing is that, so now whenever we talk about tree traversal, there are three kind of tree traversal. One is pre-order traversal, pre-order, next is post order, and next is in order. Okay, in order. Okay, so let's try. What you can do is we can simply pick any of the traversal. You can traverse this tree, then you can keep the check each of the root data, that if it is within the range of low and high or not. If it is in the range of data, then you can directly push within a vector, and then what you can do is you can directly sort it and then you can return it. What I want to tell you is this. I would explain it. I would I would explain it a little better. What I want to tell is, howsoever you try to traverse this thing, this is low and this is high. So first one is 2. 2 is not lying within this range. 4 is lying within this range. So suppose 4. Then suppose I go to 17. 17 is lying in this range. I go to 17. Then I again go to 9. 9 lies in this range. I again go to 9. And then 18 again lies in this range. I would be again writing 18. Then what I would be doing is I would be doing sort. Then 4, 9, 17, 18. 4, 9, 17, 18. This is good to go. And after that, this would be our answer. So what is the time complexity? Oh, sorry, close. Thank you so much. You don't need to be sorry. You don't need to be sorry. Okay, we are all make mistakes. We are humans. It does that. We should improve. The improvement part is necessary. Okay. The thing is that good to go. The thing is that this is all lying in the same region. So the sorting would take n log n. Sorting would take n log n, and the tree traversal would take n. So the maximum time complexity, the time complexity would be n log n. Okay. So you give this approach to the interviewer. The interviewer is quite satisfied, but he wants you to optimize it further. So how can you optimize it further? Okay, the best way to optimize this further is that you know that you need to traverse the tree. You can't change this truth. You need to somehow traverse the tree. So you need to consider all the three traversal and do a dry run of that recursion. This is the best way I have found, and this is the idea that I have myself used. These are all the 4 things. You can do a dry run of the other 2. I would be doing the dry run of the in order traversal. Why only in order traversal? Because the thing is that in order traversal would lead us to the solution, and explaining the other, doing the dry run of the other traversal would lead us to the wastage of time. So I would be doing the dry run of the in order traversal. Okay. So in order, what is in order traversal? First we would do to the left hand side, then we would move to the then we would move to the root, and then we would move to the right hand side. Just please cross check if I am correct or not, because I always confuse between these two. So just let me confirm this thing, because I can't give you wrong ideas. Just a sec, okay? Just a sec, because I always mess up this thing. Okay, in order traversal, yeah, good to go. Sorry, it's just that I always messed up. Okay, I always mess up this order traversal. Okay, when to traverse which thing. होता है ना, कुछ कुछ बातें होती है जो वहीं पर मेक मिस्टेक्स होती है। जैसे बचपन में था, एलसीएम में ही मिस्टेक होता था। पता है एलसीएम क्या होता, सॉल्व भी कर लूंगा, मगर वही एलसीएम में ही मिस्टेक होता था। Okay, good to go. So the thing is that, so we would now left order traversal. You can do a dry run of all the things, but I am doing the traversal of the left order. Okay, so we would start from the root. First we would go to the left hand side. This is 4. 4 lies within the range of 4 to 24. So we would write 4 itself. Okay, we have successfully got to 4. Okay, and then after 4 we would again go to the left hand side. Okay, this recursion, what I would write the code, it would be more clear. Okay, I would write the code, it would be more clear, I must say. Okay, what is the normal thing is that we first traverse root left. We traverse this thing. Okay, we traverse this thing, and then we print the root data, and then again we traverse the root right itself. Good to go. This is what is the code. This is the pseudo code of it. So at first, and you know that if this is not complete, then this won't do. This won't be executed. Okay. So if you can visualize recursion, then this dry run is not very much necessary. But if you have come to this editorial, I suppose that you are not well equipped with the visualization of the recursion. So you need to visualize this thing. Okay. So the thing is that we first go to the root left. The first for now, our root left is this part. Okay, and then root left would again come to this part, and then we would again go at this point. This root left is again this point, and then this is not having any left child. So after that, this part is over for root 2. Then this is there 2 itself. Okay, see 17. Then we went to the left child, that is 4. 4's left child, that is 2, and there is no 2's left child. So now this recursion would start looking back. This was looking forward. Now this is starting to look back. Now we would start unfolding it. Okay, start unfolding it. So 2 से वापस आऊंगा, तो वापस आने के टाइम क्या है, we are printing the root data. What is 2? 2 lies within the range. No, 2 does not lies within the range. So we would just be unfolding without doing anything. 4 lies within the range. Yeah, 4 lies within the range. Okay, so we would be writing 4. Then we again would be unfolding it. Okay, we again would be unfolding it. 70. This 4. Okay, this 4's traversal is not complete. Okay, sorry. So 2's traversal is complete. 2's, there is no left child, right child. So 4's traversal, left child is complete. So whenever this left child is complete, we are printing the data. We have printed the data. Now we would move to the right child. So 4's right child is what? 9. So 9 is there. So now 9 is not having any right child or left child. We won't be writing it because that would just confuse it. But 9 lies within the range of 4 to 24. So 4 to 24 is this. We would write this because this lies in the range. Okay. Now I would change the color so that you have a better idea. Okay. So now 9 is also over. 2 is also over. And now 4's left and right child are already visited. Okay. Good to go. Now we would move on now. This 17's left child is visited. If the left child is visited, then what we are doing? We are printing the root. So 17 is the root for this point. So we would check 17 lies within the range or not. So 17 lies within the range. We would print 17. Then we would, after this is done, we would move on to the right child. So right child is 18. This is done. This is how we can do in order traversal, and we can print the order in the non decreasing, that is increasing order. Okay, am I clear with this or not? Can I have a quick +1 in the chat? Then I would move on to the implementation. Okay, and one more optimization I would do. One more optimization. I would be doing one more optimization. But before that, so that I can clear the board and I would tell you one more optimization. Can I have a quick +1 in the chat if this is clear to you? And then I would move on, do one more optimization. Then I would move on to the implementation part. Okay. So can you please just reply so that I can clean the board? Because it might be the case that you have not understood any part and I need to explain again. So writing this part again. Okay, can I have a quick +1 in the chat? Please. Just a +1 or anything, just anything. Just don't write anything offensive and you can just write anything. Just anything, even dot would also do. Or if you have any doubt, you can ask me. Am I clear with this point or not? The solution is not important. The idea is important. The visualization of the recursion tree is important. It is a fact that BST is always in non-decreasing. Yeah, the thing is that it is a known fact. It is a known fact. But the thing is that if you have already known this, then you could have solved this. Okay. So what I did, that I also know that fact, but the people who don't know that fact, because it is a thing that some properties, like some XOR properties, some OR properties, this is the thing that it might be the case that you are not able to remember this thing. So I am trying to give you an alternative to this. Okay, I am trying to give you an alternative to this, that if you don't know the facts and figures, then also you can do this thing. Okay, just I want to just emphasize on this part, that even if you don't know that idea, if you don't know that fact, then you can just solve this. I know this is a known fact. Okay, so now we would move on to the optimization part. Okay, so what we are doing is, we are told that the elements which are greater than this, greater than or equal to, would write greater than or equal to root greater than equal to would lie in the right hand side. We are told this. So now whenever we coming to the right hand side, whenever we are coming to the right hand side, we know that suppose the given, what I want to tell you is that, suppose the given low is 17 and high is 24. Good to go. So now just try to see this optimization. This optimization is quite clear from this figure only. So what I want to tell you is, suppose the range is this, not this. Okay, so now suppose we are at this position. So we know that if we go to this subtree, then this subtree would contain elements which are less than 17. We know this thing. Then also we are traversing this in order traversal. We are doing that. Okay, we are doing that in order traversal. Okay, now what I want to say is that, can we skip this? Will this help us in the answer? No, it won't help us in the answer, because the elements which are less than 17 are not needed only, in the answer. So we can save this. We can save this traversal, that going on the left hand side with the elements which are less than the range itself. Then we can save this. But why aren't we saving on the right hand side? We should save on the right hand side too. But it might be the case that this is given as suppose. Now this part is clear, that if it is less than the low. Now let us try to visualize, if the given range is from 2 to high is equals to 17. Given, suppose this is given. So we know that we can save on the left hand side. But can we save our traversal on the right hand side? No, we can't save our traversal in the right hand side. Why so? Because it is told that the elements that are equal to the root go on the right side. So it might be the case that this is 17. This is 17. So it might be the case that here contains one more 17, not 18. It might be the case here it contains one more 17. So how would we know if it contains elements in that direction or not. Okay, that's why we aren't saving on the right hand side, but we are saving on the left hand side. Okay, can I move to the implementation now? So what I would do is I would simply check the data of the right subtree, okay, roots right hand side. If that is less than low, then we won't go to in that direction. If it is greater than or equal to low, then we would move on to that direction. Okay, am I clear with this? Can I move to the implementation? I am moving to the implementation to keep the video short. But if you have any queries, just text me. I would again come back and again I would tell you. Okay. Okay, so now what I am doing is to keep the recursion clean, I have initialized low and high again, which is inefficient, but I have done that so that this recursion remains clean and it is easy to understand. Okay, so we can pass this also. That would be more clean. We are again cleaning, keeping a copy of low and high. That would just be a wastage of memory. Okay, and this is the global thing. Okay, I would be returning it. Okay, why? This is just to decrease the parameters. Okay, just to decrease the parameters and to keep it clean. Okay, so now if the root is null, if it is the leaf node, then we would just return from it. And then what I did was roots data I have saved, and if this roots data is greater than or equal to the data, then we are doing on the right hand side, else we are not going it. Okay, and then if its range on the roots data is within the range, then we are just pushing it back to the vector itself. And then after that, like the in-order traversal, we are moving on to the right hand side. And then I have passed on this route, and then I am returning the vector itself, which is already declared after the public. Okay, so am I clear with this? Can I have a quick +1? I would be waiting for 1 minute for doubts. After that, I would be turning this session off. Okay, can I have a quick +1 in the chat if this is clear? If this is clear, then I would then I would close this session. Okay, and we would move and we would meet again tomorrow. Okay, if you have any doubts or general queries, then you can ask me. Okay, Anmol Raj, Ankita Kumari, Raj Sharma, okay, Swami, these all people, thank you so much for joining this session. Thank you for taking your time. Okay, if you have any feedbacks, as you have attended this session from top to bottom, so if you have any feedbacks, please let me know. Okay, how can I improve? Clear or well explained. Okay, thank you so much, Anmol. Thank you, by the way, thank you so much, Anmol, because you were helping me throughout the explanation, and it was very nice that you, after knowing also, you came to this stream. Okay, it was very much I'm very much thankful to you. Okay, I didn't got any doubts. So this is Miss Siddharth Hazra signing off. If you have any doubts, you can ask me on LinkedIn or comment your doubts in the chat itself. So that's all for today. Thank you and have a nice day. I take